Video 8, samples, margin of error, and confidence intervals. Oh my! Let's get started. What is a sample? Well, a sample is a portion of the country's population chosen to represent specific information or data. So, for example, instead of interviewing or sampling the entire population of Democrats in the United States to figure out who's going to get the Democratic nomination, we might sample maybe 2,000 people to try to figure out if Bernie Sanders or Joe Biden are going to get the nomination. Sampling is the process by which a sample size is selected. So that might be by assigning random numbers, auto-generating random selections, etc. The sampling method depends on what the researcher wants to find out. And looking at this picture down here, we can see that the population is the entire set and the sample is just a subset of that population. Let's talk about errors in sampling. The margin of error is a statement about how much confidence we can have in the result of a sample in representing the entire population. So for example, we can say we are 95% confident that the truth lies within the margin of error. This is called a confidence level. So we clearly have a margin of error here because we're not saying we're 100% confident. Unlike this joke that says the margin of error is plus or minus 100%. LOL. Tell me this. Read through these three deals and tell me which one you would take. Now, I'm guessing here, you're saying, oh my gosh, how many jelly beans are in these jars? I would much more prefer this, right? Because we have a large range here. In other words, our margin of error, we have a wide one. It's a wide margin of error. It's not as wide as that joke on the previous slide that said plus or minus 100%, but our margin of error here is plus or minus 50 jelly beans. And how confident are we in this? Well, we're fairly confident, much more confident than if we were to take this deal number 1, right? So in a situation like this, when we increase our margin of error, right, this interval here, plus or minus 50 jelly beans, that's a large range, large margin of error. As that goes up, our confidence also goes up. Like, we're pretty darn sure we're going to get the answer right. But looking at this, our margin of error is pretty darn small. We're saying plus or minus 5 jelly beans. So that's a pretty low margin of error. And how confident, and what's our confidence that this is actually true, that we guessed this? Pretty darn low, right? That's a pretty tough thing to win, being within 5 jelly beans. So let's talk about margin of error and confidence. We did an example on the last slide, but see if you can fill in the blanks. Go ahead and pause the video. All right, what did you say? As you increase your margin of error, right? Think about the jelly beans, plus or minus 50. As we increase the margin of error, what happens to your confidence? It goes up, right? Because we've got this wider range. When you decrease your margin of error, I'm saying plus or minus 5 jelly beans or plus or minus 2 jelly beans. That's tough to get correct. So our confidence is going to go down. So what's happening here? You're sacrificing accuracy, right? Plus or minus 5 jelly beans is accurate, but plus or minus 50 jelly beans is not that accurate. So you sacrifice accuracy for confidence. And here's a kind of a funny example, just like our joke on the previous slide. I'm 99% sure that the average weight of a man is between 100 and 300 pounds. Is that accurate? No. So we can say that our accuracy here is pretty darn low. But what's true about our confidence? In this case, our confidence is high because we're saying our accuracy is crazy. We've got a huge margin of error here. So we're pretty darn confident that this is going to happen. So if I go back to this previous slide here, we can really see that if you increase your margin of error, that means you've got a really big range. This is low accuracy, isn't it? Because you've got a really large range, so it's low accuracy. And if you decrease your margin of error, so that's kind of a small, we're saying the average weight is between 120 pounds and 122 pounds, right? So this is going to be high accuracy. All right. Let's go ahead and move forward. I want you to take a second to write this formula down. This is our confidence interval formula. Let's go ahead and pause that video. All right, you're back. So let's read this question. It says, you love batteries, like LOL, who does not love batteries? However, you hate that they die so quickly. So because you're on quarantine, you have so much time to test out 100 batteries, and you find that the average battery dies after 85 hours, and you've got a standard deviation of 6. So let's just quickly write that our X bar is a sample of 100. We've got 85 hours. That's how long a battery lasts. And FYI, we've got an N. That's the number of items in our sample size is right here at 100 batteries. And we also have a standard deviation of 6. You can write S or SD, up to you. So this question is saying, give me a 95% confidence interval for the actual average battery life. Well, what is a 95% confidence interval? Let's go ahead and look at this confidence interval right here. Where would my 95% be? This is kind of a throwback. So my 95%, as a reminder, was from here all the way up here. What is the z-score that represents 95%? Now, if you just said 2, you're totally correct. So in this particular case, because we're talking about a 95% z-score, I'm going to say my z is equal to 2. All right, that's really important information. And now we're going to go ahead and we're going to plug in. So my X bar, here we go, plugging right into these formulas. My X bar is 85 plus or minus my z-score of 2, because we're talking about a 95 percentile. And this is going to be standard deviation on top. 6 divided by the square root of n. Well, what's my n? My n is the number of batteries tested out. In this case, we've got 100. Okay, let's go ahead and make this a little bit better. This is 85 plus or minus my z-score of 2. Okay, 2 times 6 is 12. And the square root of 100 is 10. So this is 85 plus or minus 12 divided by 10 is a 1.2. Well, what's 85 plus 1.2? That is an 86.2. And what's 85 minus 1.2? Well, that's going to be an 83.8. Let me make sure that's right. That is correct. So what's our range? We actually have to write a confidence interval. When I'm asking for this, I definitely want you to write a sentence. Okay, so you're going to say that I am 95% confident that the actual average, and technically we're talking about the actual average of the population, but we don't need to say that. So I'm 95% confident that the actual average battery life is between 83.8 and 86.2 hours. All right, that was our first one. We got to try another one. All right, here we go. So we got a situation here where two people are arguing about which sport is better. So what we have is Cody thinking that baseball is the bomb and Abe thinking that soccer is life, although that's spelt wrong, life, L-Y-F-E. They argue about which one is better and decide to survey 150 people to get a good idea of which sport people prefer. So what's our N in this situation? Well, 150 people surveyed, that's going to be 150. My z-score, what's my z-score? Well, in this problem, I want a 68% confidence interval. And we can deal with 95% and 99.7% later. But in this case, if I'm dealing with a 68% confidence, okay, what am I talking about? I'm actually just talking about this section right here. So in this particular section, we've got a z-score of what? Exactly, of 1. So my z-score is 1. My standard deviation is found in the problem. Looks like our standard deviation is 1.5%. It's pretty low. And what else do we need here? X bar. Okay, what's the average? It looks like 70% of the people prefer soccer. So that's a 70%. All right, so let's go ahead and plug in. So we've got X bar, which is 70% plus or minus the the z-score, which is 1, times the standard deviation, which is 1.5, divided by the square root of n, which is 150. All right, that's going to end up giving us, I'm just doing some quick calculations, 70 plus or minus 0.636. So the plus version of that is going to give me obviously a 70.636. And the negative version of that is going to give us a 69.363. How did I get that? For this one, I added 0.636 to 70. And then how do I get the lower one? Well, I actually subtracted 0.636 from 70. So what's the statement that I can say? I can say that I am 68% confident that the actual average is between 69.363 to 70.636. Now, this is a 68% confidence, so we are not that confident, right? Our confidence level is down, but what's true about our accuracy? Actually, our accuracy is pretty high. And what's true about our margin of error? It's pretty small, it's pretty low. Okay, so we've got that relationship. Now, I don't think we're going to go through and do 95% and 99.7, but let's say you want to practice it. What would you set your 95% confidence z-score at? Well, looking back here, a 95% would be a z-score of what? Yeah, of 2. So you would redo this entire problem, but the only thing that would be different would be that you would make this a 2. All right, now, last one here. If I asked you for a 99.7% confidence interval, so 99.7%, what would you let your z-score be? In this case, I would note that it's going to include these values right here for 99.7. And that's going to be a z-score of 3. So again, what would change? Go back and look here. We would change that to 3. And note that if we say a 99.7% confidence rate, then our margin of error is going to be pretty big, right? Because we're being really confident that we're correct, so that margin of error is really large. However, our accuracy is very low. All right, last one here, before we get to our review, of course. So let's create a 95% interval for Manson's average SAT score. Note, 100 people were surveyed and the average SAT score was 530 in math, standard deviation of 50 points. So here we've got an X bar, an average of 530, plus or minus, because we're 95% confidence, we're talking about a z-score of 2. Our standard deviation is given to us in the problem as 50 points, divided by the square root of how many people? 100. So this is going to give me 530 plus or minus 2 times 50 is 100, and 100 divided by the square root of 100 is going to be 100 divided by 10. That's just going to give me 10. Well, what's that going to be? That's going to be from 520 to 540. So I am 95% confident that the average is between 520 to 540. Outstanding. All right, this is just a little bit of review because heck fire, why not? Let's just do some review. So a review question here says, Mara has scored a lot of runs this season in softball. She has a z-score of 3. If the mean on the team is 4 and the standard deviation is 2, find the number of runs she has scored this year. So we're going to let x equal z times standard deviation plus x bar. This is a formula we derived earlier. We're just going to plug right in. So we get x is equal to a z-score of 3 times a standard deviation of 2 plus an average on the team of 4. So this becomes 6 plus 4, which gives us 10. So what's that answering? How many runs has she scored this year? 10 runs. All right, just a quick little review for you. That's it for this video. Thanks so much for joining us. Make sure that you hit subscribe because I'm really into likes and views because I want to become a famous YouTube mathematician. Thanks again. Happy travels.